Parallel lines have the same slope, so when we write an equation of a line that's parallel to a given line, we first must determine the slope of the line that's given. Subtract x to isolate y and rewrite the equation in slope-intercept form. The coefficient of x will be your slope. Next, substitute the slope and the coordinates of your ordered pair into either point-slope form of a linear equation or slope-intercept form. If you're using point-slope, y minus y1 equals m times x minus x1, distribute your slope and simplify the equation. If you're substituting into slope-intercept form, solve for b, and then substitute m and b back into your equation. Repeat the same process for number 2. Subtract 3x from both sides and then divide by -5 to isolate y. Your slope will be 3/5. Now substitute the slope and the ordered pair for xy into your equation. Distribute 3/5 to simplify and then add 8 to isolate y. Now your equation is in slope-intercept form, y equals 3/5 x plus 11. Perpendicular lines have opposite reciprocal slopes. We'll rewrite the equation of the given line in slope-intercept form to find its slope, dividing each term by 8 and then simplifying the expression into y equals -1/4 x plus 5. The slope of our given line is -1/4. We want to determine the perpendicular slope, which is the opposite and reciprocal, +4/1. We'll substitute the x and y coordinates into the equation, distribute, and isolate y to write the equation in slope-intercept form. Notice that the slope of the original line was -1/4, and the slope of the new line that's perpendicular is +4. We'll repeat this process on number 4, adding 3y to the other side of the equation and dividing by 3 to get the equation into slope-intercept form. The slope of the given line is -4/3, so the perpendicular slope is +3/4. Substitute these into your equation, distribute, and isolate y to write the equation into slope-intercept form. Y equals 3/4 x minus 8. For number 5, the equation of the circle tells us that the center is 3, -4. Remember that the signs are the opposites of what you see in the parentheses. The radius squared is 9, so the length of the radius is 3. We'll plot the center on the graph, 3, -4, and then we'll count 3 units in each direction to complete the circle. To write an equation of a circle given a graph, you want to identify the center of the circle. Make sure that the radius is equal in all directions. Here the center is 1, -1, and the radius is 3. Square the radius and substitute the coordinates of the center into the equation. For number 9 and 10, the center and radius are given. Simply square the radius and substitute the coordinates of the center into the equation of the circle. Remember that because the circle equation is x minus h squared and y minus k squared, the signs inside the parentheses will be the opposite of the signs of your coordinates. To find the center and radius for each of these circles, we'll need to rewrite the equation into standard form. We'll have to complete the square to do this process, so we'll group the x terms together and the y terms together, then we'll subtract 141 to the other side of the equation. Now we're ready to half it, drop it, square it, and add it for both the x's and y's. Remember that the sign inside the parentheses should match the sign of the b term for that variable. Combining like terms on the right, we see that r squared is 5. The center of this circle is -5, 11, and the radius is radical 5. We'll repeat the same process for number 12. Group your x terms together and your y terms together and move 109 to the other side of the equation. Now we'll take half of 4, drop it into the parentheses, square it, and add it to both sides of the equation. We'll do the same thing for negative 22, and then combine like terms on the right. The center of this circle is 2, 11. The radius squared is 16, so the radius is 4. On number 13, the coefficient of x squared is 3, so we'll divide each term by 3 throughout the equation. Then we'll move the x terms together and the y terms together and subtract 12 to the other side of the equation. We'll complete the square for the x's, dividing negative 10 by 2, dropping it into the parentheses, squaring it, and adding 25 to both sides. Then we'll half 12, drop it into the parentheses, square it, and add 36 to both sides. Combine like terms on the right to get 49. The center of this circle is 5, 6, and the radius is 7.